Everyone, and welcome back. Today we're going to be looking at scientific notation. In chemistry and physics, oftentimes we deal with very large numbers and also very, very small numbers. Allow me to please demonstrate. Let's say I ask you guys, how many molecules of water fit into a simple average pen cap? What would you guys say? The answer is this number right here. It is 3346 followed by 19 zeros. Obviously, this is an excessively large number. And if we're talking about, distances in space, this number becomes even more daunting. So there's a clear need to represent numbers in a much more efficient way. And that way is the scientific notation. So the following number actually is represented by 3.346 times 10 to the 22nd. By the way, does anybody know how to even pronounce this number? It is 33 sextillion 460 quintillion. That is a mouthful. Every time, if we had to, when dealing these numbers, had to, enumerate them in that fashion, it would take forever. So scientific notation takes this away, takes very large numbers, and breaks them down into smaller, more manageable parts. So let's see. What are the parts of scientific notation? We have a number, that's called the coefficient. We multiply it by another number, that's the base, and we raise it to an exponent. Those are the three parts of scientific notation as opposed to standard notation. But what does that mean? Imagine we have the following number. We have 5 million. What is another way by which we can actually write this number down? We could simply take 5, multiply by 10, 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 6 times. And if we do that, if we put this in our calculator, we see that we come up to exactly 5 million. So we can then take the 5, and since we are multiplying it by 10 6 times, we can simply raise it to the 6th power. So it becomes just like this: coefficient, base, and exponent. So let's check this out. What are some of the rules now for writing scientific notation and converting standard notation into scientific? Well, we have 3 different rules. For numbers that are greater than 10, you have to slide the decimal point to the left until the coefficient becomes less than 10, and the number of decimal slides becomes your positive exponent. Allow me to please demonstrate this in our trusty sketchpad. So we go to a sketchpad right over here, and let's say we have to convert the following number, 450 million, and we have to convert that now from standard notation, so this is standard, into scientific. So what do? Imagine over here we have a decimal point. So what do we say? This number is clearly larger than 10 by a lot. So what do? We slide it, we said, to the left. So the number of decimal slides now becomes the positive exponent. So we go 1, 2, 3, 4, 5, 6, 7, 8. So it becomes 4.5 times 10 to the 8. Okay, now notice how the coefficient, when we slid the decimal point, became less than 10. It became 4.5. So it becomes 4.5 times 10 to the 8th. That was easy. Let's go back to our presentation. And continue. For numbers now between 1 and 10, what are we going to do? We're going to use the base and the exponent of 10 to the first. Because everybody knows 10 to the first is 1. So let's go back to our trusty sketchbook. So here is now another example, okay, of standard notation. So let's say we have to convert this number from 6. We got to convert this now to scientific notation. Again, we need a coefficient and we need a base and an exponent. In this case, because it's a number between 1 to 10, we use 6 times 10 to the first. Very, very easy. And then finally, the last rule for converting standard into scientific notation, we are going to use, so for numbers between now 0 and 1, we're going to slide the decimal point to the right until the coefficient gets to a number between 1 and 10, and the number of decimal slides becomes your negative exponent. So going back to our sketch pad right over here, we see, let's say we have the following number. So we have 0.000000291. So we got to convert this now into scientific notation. So what do we have to do? Because now this is a number from between 0 and 1, we have to slide the decimal point to the right. And the number of decimal slides now becomes the negative exponent. So let's check this out. So we go from here 1, 2, 3, 4, 5, 6, 7. So it becomes 2.91. Because I moved it 7 spaces, it becomes times 10 to the negative 7 now. Notice how this is a negative number, and this over here is a positive number because a number larger than 10. That's it. Very easy. Thank you so much.